Hi everyone, I'm Rishabh Sahu, a software engineer at GeekyAnts. So, do you think that live streaming platforms are just boring where one person sits and continuously talking without having a feedback from the viewers? So, today we are going to build a platform where users can actually interact, give feedback, and actually affect the flow of the video streamings. So, let us talk about what's the problem statements and what solution that we are providing. So most of the video platforms are just passives where you just max you can drop or comment or really or interact or just send the emojis or anything that not affect actually the streamings. So we wanted to flip that experience. Imagine if a viewers could vote, could tell, could interact and actually change the flow in real time. Think of a live debate where audience could actually decide who is winning. That's the vision we are setting out today. So what actually we are the solution that we are providing? So we are providing a solution by building a platform powered by the 100 ms for the video streaming, and we'll build our own custom WebSockets for the voting systems where people can vote to change the flow of the live streaming and decide who is actually winning in a debate or a discussion. We'll have a features like live streaming. We'll have a feature like real-time voting for the peoples. We'll have a feature for people to chat and also send emojis reactions to them. The tech stack that we have used to build this is Nextjs, Prisma, WebSocket, 100 ms for the video streaming, and Nextjs as in the backend. So why 100 ms? So if you try to build a live streaming platform from the scratch, you usually start with WebRTC. That means we have to handling the signaling system like STUN and TURN servers. Then we have to manage for the peer-to-peer connections for hundreds and thousands of users. On top of that, we also need to build features like recording, role-based access, and chat reactions and everything, chat SDKs and everything. So according instead of reinventing that, we totally rely on 100 ms for that. 100 ms gives us out of box SDKs for web, for mobile, iOS and Android both, and it works simultaneously with across all three of them. On top of that, 100 ms also provide us the features like recording, analytics, role based access to the persons, chat, emoji reactions. So we can use these 100 ms to make our work more easy rather than spending months on just low level video challenges. So let's talk about the architectural diagram of our platform. So we have separated the responsibilities into three main layers: WebSocket connections, 100 ms connections, and database. In 100 ms connections, we are handling all the video and audio related streamings. This provides us the low level latencies in the videos and audio streaming without reinventing the entire wheel. In WebSocket connection, we have completely separated it out from the video layer to keep it separated. In WebSocket gateways, we connect to users every single peers. So when someone casts a vote, it directly reflects on every single one of them without affecting the video layer. We have a backend layer which handles all the persistent storage like scores and the broadcast scoring. So we have a database layer built in with the Nextjs and Prisma that handles all the business logic, authentications, and database interactions. It stores the user's profile, broadcast count, and also the scorings and historical session datas. This separation is intentional. The 100 ms handles only the chat, interactions, and WebSocket connections, handle all the scoring related environment, and the backend layer APIs only handle the persistent storage and business rules. This moderation makes the system more scalable and more reliable, independently working as two different highways. In short, a video and engagement are coupled, which give us more flexible and performance at a scale. Talking about the integration of this entire workflow, so we have three steps in it. Step 1, when user joins the rooms and the video streaming begins. Step 2, we open a WebSocket connections to handle the real-time interactions. Step 3, the backend synchronize the both states so user always see the correct participants and also the correct live streaming votings. Talking about the step 1 of joining the functions. This is actually the magic happen. It is an entry point that everything brings together. Looking at the function, first we call the connect function to make a WebSocket connection with our backend. Coming up next, we use hms.join functions to connect to the 100ms cloud. This separation, looking at this, you can clearly see a separation. This separation is crucial for our architecture. In HMS action.join function takes several of the parameters like username, authentication token, settings for the audio and the videos, and metadata information about the user's profile. The remember action selections to makes the 100ms select the last selected audio and the mic of the person. The capture network qualities check the capturing before making a join functions to make the video streaming more reliable and more efficient towards the frame drops. So if we look at this, there's a two separations and this separations has made intentionally. So let's suppose if the cast of votes goes up, it does not affect the video streaming, or if there is any problem with the video streaming frame drops, it will not affect the voting system of ours. This architecture gives us both worlds, a professional grade video streaming from 100ms and lightning fast voting system through the WebSocket connections. Now let me show you the WebSocket connections actually work. It's actually quite simple. We just need to connect through the three little things. First, we initialize the WebSocket functions by using an access token that makes the connection secure. Then we connect to the server through the WebSocket. And finally, we subscribe to the broadcast and gets the update about the broadcast. So whenever someone reacts, votes or sends a message, we get event instantly. That's it. In just 3 lines, we got a secure WebSocket connections powering real-time engagement. So we'll do a quick demo and see how actually the things are working. So we'll do a quick demo. So this is the place where actually we are entering into the broadcast, and at the same time, it also triggers the WebSocket connections and the 100ms connections, and the backend will sync both of them. So if I just enter the broadcast, it just make a WebSocket connection as well as the broadcast is connected to the call. So if you see, I've joined the same call as the viewers. So if we cast a vote here, it reflects directly on the both side. And it happening from the WebSocket connections. It triggers an event whenever someone votes and updates the scores on all of the peers. So if I do the voting again to the another one, it just keep updating it. And it is that simple. The video streaming is completely be handled by the 100ms and the votings are handled by the WebSocket. So even if the vote cast increases there's a spike in a voting, it will not affect the video and the quality because it is handled completely on a different layer. So if we talk about the future enhancements that we can make on this same project, is like we can add AI moderations, which can just summarize the broadcast call by just listening to it. We can also add multi-language live captions to it, a GraphQL subscriptions, and advanced analytics, which can gives us the voting analytics of it, tells the tone of the broadcast, and other enhancement. There's a tons of enhancement that we can make to this streaming. So what we have learned today? Today we have learned that we should not put one tool to handle everything on our platform. So what we have done today we have handled it a voting completely on a different WebSocket and videos on a completely different platform like 100ms. So in that way, we have a more scalable architecture. If one goes down, it does not affect the another one. And if there's a spike in voting systems on anything, the video frames will never drop because it's working on a two different architectures completely. So, and we have to build a monitoring both systems independently, handling errors. It makes us handling the errors more gracefully and drop the probability of video framing getting dropped because of more traffic. It never ruins the experience of the users of the streaming because of the WebSockets handling the scoring part. So that's it. Thank you for watching GeekSpeak. If you like this breakdown, please like, subscribe, and give us in a comment what new features we can add to make it more interactive or engaging. Stay tuned for the more behind the scenes update. Thank you.